Hello, my name is Collin Ng, and this is Lab 1, Constant Velocity, from Physics 2211. The purpose of this lab is to observe an object that is moving at the same speed without changing direction, and comparing the object's predicted motion versus the actual motion. We will be using Newton's first and second law, which this first law states that an object in motion stays in motion unless acted upon by another force or inertia, and his second law describes force, which we will get to in a moment. The A preview of the lab is that these laws and conditions will prove that the object will move in a straight line at a consistent speed. And these are our models. The main physics idea behind it is Newton's first and second law. His first law states, again, that an object in motion stays in motion unless acted upon by another force, and his second law describes force as mass times acceleration. But it can also be redescribed by taking the integral a couple times as the velocity update formula, which is on top, and the position update formula, which is on the bottom. The reason we are using these laws is the first law will um, we use the first law because the object is not being acted upon. We use the second law to predict what will happen to the object as time moves on. And in this experiment, the system is the slider, and the surroundings is the track, the atmosphere, gravity, life in general. The initial conditions for this experiment is that the system will start 0.178 meters away from the origin, so that vector, and the velocity will be 0.282 meters a second, so that vector. And this is a video of the experiment. I trimmed off the beginning and ending, which the beginning had a slight issue with the camera, while the end had the bump at the which is not included. And this is the code that shows the experiment. Above is just visualization of what's going on here. And the initial conditions are posted here like they were earlier. The delta t was edited based on what tracker felt like setting the delta t to. And here are the two equations that were shown earlier, just with new, well, the same variables assigned. And that leads us to these results. On the left is the experimental data, and on the right is the simulated data. There are a few possible errors with the experimental data. For example, my shaky hands while recording the video may have influenced the scale, and human error may have also influenced the tracking software because the object is manually placed throughout the video, and then that tracker takes that data and etc. The human error may have influenced where the object was placed. For the what if questions, what if you changed positive x to negative x for your scale? The results of the data would look similar. The slider would continue to move away from the origin, so wouldn't the numbers wouldn't change. They would just change from positive to negative. So the graph would flip over the x-axis. So the line would point down to the right instead of up and to the right. And is it possible to say how many pushes and pulls are acting on the system to give a result of zero net force? No. It is impossible to count the total amount of pushes and pulls all added together. Anything from a small microbe on the track to the air conditioner could lead to a force acting upon the system. There are too many factors in reality that are affecting the experiment, so to count them is pointless and futile. The only forces great enough to make a visible difference is the initial force that pushes it to the right, which was me, and the friction counteracting that force. That net force led to around zero. In conclusion, this experiment shows that Newton's first and second law apply to an object that moves at the same speed and direction. Thank you for watching.